using Neo4j. So my name is Victor Chang, or you can pronounce Chang. And recently I'm in transition to move to Aston Business School, but I still have my student at Tisa University, so I can do both computing and business, both teaching and research. So motivation, Neo4j, it might be very new to lots of you. The reason is because you probably have learned databases that has been around the market for more than 30 years, like SQL, SQL Server, and so on. But because now we have too much data, too many information, they're all over the place, and too many tables, you have to do link tables, you have to do so many links, and now it's getting harder and harder to find the correlation and how people or objects are related. Therefore, we used a graphical databases instead of the typical the relational database management system, because they allows us to see things clearly. And obviously, it has the advantages that being able to read and write very quickly, and then to find the information and to save everything very quickly and easy to learn and use, and so on. So before going into detail, you just look at what the examples, because these are the graphical interfaces that you can have the idea within seconds, even though you don't have to understand everything. But then you know the console, how is it related to different person, and then each person or organization is anonymized so that it also has the privacy. And then you then have the bit of understanding between different individuals, and each person is a name, a number, so that at least you know how they are related. So I'm going to give the talk as follow: graph, databases, and Neo4j, the objective of the paper, the data modeling and extraction, experimental analysis, and conclusion and future work. So the graph databases. So as you know, typically, whether you are in business school or computer science, you have to learn a little bit on databases. Like at least you know what databases are, and with a very simple way to use them. But now, simple databases are not able to cope. Therefore, graph databases might be one of the solutions, because it allows us with a better flexibility and scalability, and allows us to join nodes and to join tables easily. So we don't have to go through with SQL queries, because if you do a lot of queries, then you may then end up like doing this for several hours a day. And therefore, graph databases will save your time and make it more efficient. So Neo4j is one of those examples. So this is how it looks like. For instance, it's open source, highly scalable, and it's allowing all the good features for the software, being atomicity, consistency, isolation, and durability. For further detail, if you do not mind, you can find out through Google. Yeah, due to the time constraint. Then with a graph data science, it allows us to link to different departments. Let's say if you are involved in a project that involved with different departments, or even some of the local councils, and then if let's say you are running there as a business, and you can have your application or services working for different domains, and then they are related to the key people or the key projects. So it gives you an idea within 1 or 2 seconds. So for Neo4j, it's a disruptive technology, which means that you are using the latest technologies such as AI, such as blockchain, such as data analytics, and so on. It provides a developer and data scientists a state-of-art techniques, because we don't have to spend too much time on programming, because I think our focus is on a business solution. We have to provide a solution for business and organization, rather than if you spend too much time on programming and debugging, they already lose the purpose. Then we can manage the cloud service, and we can then jointly work with other cloud service provider, or we can then decide not to, because you can just click there and then make a decision within seconds. And you can also support other Java or other languages, and the structure make it easy, because graph means that it allows creativity and imagination, because for databases you have to do this the statement from where, and then you do the queries. But graphs create your own imagination. You can link to anybody, any project at any time, and people with I think the keynote this morning, like you don't have to expect to have a high level of IT knowledge. At least you probably just have 1 hour training, then you know how to use them. So you remove the restriction and you can run it with your own data analysis requirement. So there are a lot of words. In disruptive technology, you probably heard about algorithm, but for business school, we don't have to learn how. For computer scientists, we do. But even you know how to do this algorithm, they may spend you like several weeks to several months. So it loses the purposes. For businesses, time and resources are very important because we cannot spend too much time developing something that may not be proven to be serving the companies or your clients. So therefore, we used any tools. So in this tool, it allows us to find the interconnectivity between nodes and relationships, means between people and project and the relations, finding a similar sets. Because when you have more projects, you may try to find any similarity so that you can get the lessons done before, measure the nodes and relationship, because sometimes the measurements are hard to be quantified. Therefore, you provide an alternative solution ranking the nodes and entities. It means that maybe you have too many projects and you cannot know what is the importance and priority. So it helps you to rank and prioritize, of course, because we're too many tasks that we have to prioritize. And node calculation, it then knows like the importance of each project and the relation to those people. It then give you a simple answer for that and find the shortest path, because when there are many ways to do the project, then the problem is that you get into chaotic and unstructured way. So it then finds the shortest path and the nodes embedding, which means they give you some advice on that, and the strong connected components, which means that it may suggest you to find, for instance, people with a stronger relation to you to solve the same problem, or maybe like you have worked with some businesses with successful implementation case study, then it allows you to go back to them to work. So the data modeling abstractions like that, the console, for instance, is linked to the region. So then you can see this is the kind of action, like you have the action with them, and then now he sends back, oh yeah, oh, can you do me something? Yeah, we can do that under certain condition, please. Usually in the UK, is council takes money, no project. Yeah, you're like you know, even it's very strange. Like it's your garden, you want to have a a small room or maybe a conservatory. Then it's in your garden, you still have to get a council approval. It's very funny. Oh, yeah, as long as you pay the money and and work with a local project. Let's say you are a contractor. All right, you get the cables or upgraded to fast fiber optics. Oh yeah, you work with that school. They will help them to improve the IT systems. You work with the hospital. You change to smart wearables and so on. So it gives you a very quick indication. Because now we work with so many people and so many projects, sometimes we cannot forget, remember everything. And databases are too static. Therefore, the graph visualization help massively. It contains the nodes and relations and region nodes and so on. So it allows us to know everything very quickly. So we have to perform experimental analysis just to see whether it works. So it may be getting very complicated. Let's say if you work in a large company, without naming which company, but just a similar example, if you work for IBM or Accenture, like you work with many clients, you work with many projects, you may lose the information. So what you do is that you put them or who they are and what project, and then if you click something, then you show, oh, this is a project, you have finished that project in, let's say, June 2018, and then give a summary what the project was, what was that. But this gives you a top overview so that you then have understanding. You can record the entire life, like all the project you've done and all the important people you have met in such a way. So the aggregation of network, maybe, let's say you get more involvement, then you will get more and more, and then you can repeat this. Then you can also work with an international project. So in a way that if let's say you only focus on London or maybe out of London, then it gives you some tables. So it also allows you to work with the traditional databases to give you a simple table like that. So in a way that you then calculate the similarity, means that, oh, this might be something you have done it before, and it depends on how you define. For instance, let's say I have done some projects and you give some criteria, and then you will then calculate the similarity for you. So at least you know, oh, let's say you then have more choices. Oh, a similar project, I've done it before, they have some similarity. And of course, you can then perform the experimental analysis, because let's say when the privacy is a concern because you cannot release certain information. So you have an anonymous ID. So it's a way, oh, this is linked to that. But then you can also even rank them in the sequence. Let's say, oh, you have to talk to the project or person, and then after that you get the approval, you get there, and then after that you send to another government official, and after you get approval, this is the actual real boss. But you can also, without naming any sequence, so that even people got the data, there's nothing being leaked because they don't know the insider's knowledge. And at the same time, it creates a very useful roadmap, because you know who will be the important people to talk to. Because the problem we have now is that we have a lot of things. We may not find the right person or the right approach. So similarly, you can also expand it, because when the network is getting more and more complicated, you sometimes may have to seek for external collaborator, or maybe you have to strengthen the relations between different entities. Then you will be able, if you can find solution within here, then that's fine. Then if not, then you can go outside. And sometimes some people maintain a good relation because you sometimes need a contractor to do certain tasks. So at least that it gives you the way to know. And then there, of course, there are some restriction, because you only allow the highest scoring candidate, which means that if there's somebody not so related to you, so the system doesn't think that it's relevant. Yeah, so it's only focused on the people or the project that that's probably more relevant to you. Yeah, so you can also based on the ranking or the similarity score. Then you can also optimize. What does it mean? That means that you want to strengthen the relations between different entities. So this is how you should just, for instance, I'm based in Northeast, then I have to strengthen the relation with Newcastle and Durham, better universities. But now I'm about to move to Birmingham, then maybe my university with other colleagues, and also University of Birmingham is not very far from London and Manchester, and probably I can also work with top business school. But then you will ask me to strengthen the relation within your own region before you go to other collaborator. Maybe still continue working with Patricia, Mitra, and also the new collaborator like you. But then they say, oh, please fix your own problem first before you want to make more friends. So it gives you the idea and suggestion what to do. But also algorithms is a kind of summary between some computer programming and mathematics. So some mathematical modeling may become some graphical interfaces, because we can then calculate the local clustering coefficient. Means that if, let's say, I fix my own issue, and let's say if I strengthen the people inside my project or inside my region, then it will get a 1 score. So from 0.6 to become 1. So the system then seems to think that I can go ahead. Then find the shortest path, because that's so important. Why? Because in some project you will find it's so common. We make a big round, big trip, and then wasting a lot of time, and it's like the project that can be done in 1 year. And one of the common problems is that it become 2 years, then 3 years, and like UK NHS, National Health Service, is always like this. And then like when they build the Olympic project, although they are trying hard to finish on time, and it's always like this. So finding the shortest path is important. So once the system understands the network, the issue is that you have to give data that's almost like a reflection of your life to the system, and the system may then find some shortest path and make certain suggestions to you, and then in a way that you can maximize your own efficiency. So the experimental analysis between node embedding and the node 2-vec is that now there are some advanced features. Advanced features allow you to use a vector representation. Sometimes you can then calculate that sometimes you want to know some strangers, then you do not know who they are, and then you may then suggest you some approaches like there's a saying like 6-degree Like you will find anyone from Earth through the network of 6 people or within the network of 6 people. So sometimes it may also suggest you that way, and it may get very complicated. Like, oh, you connect to somebody or some project, and then will get connected, and then it will become a very complex network. And there's a different research. It's like when you have a complex network, then how you are going to manage. But in this case, I just want to demonstrate that it can be done. Yeah, and before we get age of retirement, at least you show the relationship between people and project that is helpful. So because of a time constraint, so I want to make a conclusion here. So in our research, we then have the following contribution. First, we provide a streamlined workflow to explore the intrinsic nature of the real world processes, because some of those things is only us. We know who are the people we work with more recently or more in depth, and we also know whom are the people we work with in the past, and they might deliver the same project. But then this is getting hard to be done on normal databases. And also the knowledge extraction will be helpful to use graph databases such as Neo4j, provide different algorithms without you to know how to do programming, because we can focus our time on business processes and solution, and to model and predict the complex phenomena. Because when you get more and more people and project, the system will become very complicated, and therefore we can work with sentiment analysis, natural language processing, and Neo4j. So we can then use some of the latest technology together with the software and to explore the advanced techniques and the new research focus. So in the way, we make our work much better and much more improved all the time. So there are a lot of references I've used. I've selected some, and then if you have any questions, you can email me, and then I can let my team member to answer you. Thank you so much for your time, and I hope you can understand my talk and presentation. Thank you.